Hello everyone, welcome aboard. This is again the special session of TEGS. Again, TEGS stands for Technet Earth Global Symposium, and we'll continue like that another uh, week or so. And Christopher O'Neill, who is the original IT person who organizes and designs and also configures all this. Uh, we'll be back on 23rd and we'll start in a couple of weeks and then we'll start our regular sessions, the conference meetings. Uh, Presently, Christopher is at China. He's presenting his PhD thesis. So he's on a research conference uh, there. Uh, I think he's presenting in person live there. So he'll be there. He should be back in a week or so. And Himalayan Markakis, who is proceeding with many different directions and progressing really fast uh, in physics of superluminarity. That I worked with him, and we have published papers. So we have projects that's going on, but we have gone into understanding about gravitonic physics, which is the fundamental thing uh, that's missing now between the relativity and the quantum mechanics, especially the standard model. Um, Although they have done a lot of verifications, we still have a problem of incorporating gravity. So quantum gravity that I worked on called modified uh, Newtonian dynamics is called mount, but I did a more general transform of that, and I could do that universe is black box again. So that essentially tells why it's difficult for us to characterize the whole quantity, although we are getting a lot of data from black holes, things like that, and we don't know what the dark matter is. So we believe that's superluminous from the Emmanuel school. So he's both experimental and theoretical physics. So he's putting together all that in his PhD thesis of electron configurations and topology. So he's working with that. And then we have, I have Emery Taylor who's working on discontinuum physics, and I do the math, and he has done fantastic arguments why relativity and quantum mechanics may not be the fundamental thing. So we have to come up with discontinuum energy fields, which may be the fundamental thing from which everything is formed. The discontinuum is, I'm trying to do very abstract one to prove that why discontinuum may be the fundamental thing. Uh, and that is also bolstered by Christian Wolff's work on I space, which means that it's not really a zero space. There is no zero, but it's I space. And my two theory also proved that uh, you can prove from group theory, that crystallographic group theory, that actually there is no the zero has a value. The zero space that we call as a value for I or j, and so a point is just an observable things that become closer. Anything from far distance looks like a point, come closer, there are more features into it. And then if you look at Earth itself from a far space, it will appear at a point. There are so many features on Earth with life and everything. So, so it's a observer perspective, a point. So there may not be a particular zero point per se, but it emanates into many dimensions that the string theory also talks about. So I have put all this together also to make sense for me. So it's essentially a black box, and then you have transforms, inverse transforms, things like that. Recently, I found that there's a connection. What we see is an image, and image is like a function, and then we can transform to a series, a function. Uh, So we are going from non-linear to linear algebra. So now a function is like a non-linear algebra, you can say in general, and the matrix we know is a linear algebra. So there is a connection between that and the series comes into the picture. And the transforms are something that helps to uh, you know, go from one to another, or from the non-linear to linear, or linear to non-linear. Again, that's because the general transform that I have done with all the transforms that's available, like the Fourier, uh, Lagrange, Hamiltonian, Legendre, and Laplacian. So all these transforms I put together wherever it's necessary to convert one space, and then finally to rotational and time domain. So that's the final aspect, and then we can find the eigenvalues. Again, the Hamiltonian that we talked about in the Schrodinger equation is a linear function. It's a linear, so that's only valid. I have proved that the, the time being linear is only valid for for a very short time space, which is like half a kilometer or so. And I have put in uh, paper article, and it shows that the time itself may not be linear. We use linear time, of course, all the time that we are using. The clocks that we use are linear operators of time, uh, of the rotations. But we can see from there, I have proved in the paper pitch that actually we don't know the events are you know, kind of what you call separated, or there's a discontinuum because of the fact that this is only the linearity is very different. So we have to find some other way to connect that. So if something's happening within that 500 meters, we need something to connect the information. And so that's the main connection. Okay. Uh, so it is happening in in that space, like in an arena. Then we need some, like a television or some other internet or something that tells us and brings us the information. So the information itself then is created within that event. Uh, we need something that will transform it, and then we extend that. We have these cells. Then they are discontinuous cells. So the information from to another goes in one direction, and the time goes the other direction. So it's a complex process, but you can get some algorithm that have some algorithm that connects with all that. So again, the image then can convert to a series of images, then can form a video. That's in a general application to IT. And this video then can transform it, because that's like a pattern that can be described by a matrix of series, and then we can do the transform and get communication. Again, that's highly complex, and eventually I think we'll be able to prove that. These are ongoing understanding, conjectures, and ideas that has to be tested. Also, it can be proved from algorithm. There are some algorithms I have developed, and there's some algorithms available, and we know quantum computing and the algorithm associated with that. So those things can be put together, as well as the AI, the machine learning, all these come together. ChatGPT 4 and then GPT-4, everything comes together. We need all that in order to understand the holistic aspects of how image then becomes video, and then the video then becomes communication, and then the communication requires inverse transform, which would involve matrix information. As we know, the matrix information still is a big problem, and even if you do Christopher Simple, all those applications of tensor calculus that's done with the relativity and also standard model, all the theory of everything equations and things like that. They essentially are linear functions, but we have to convert it to non-linear things, which involves matrix inversion. So back to a functionality type of thing. So we get functors and functions and functional things like that. And I have actually a true formalism of connecting the matrix or the site to a functional aspect. I published along with Manuel Malabar, so that's only fairly fundamental math that's involved the matrix algebra. And we know that matrix is non-commutative, so you have to do the operations in order to do the matrix inversion, and all those things are involved in that. Again, matrix inversion, even now with supercomputers, is extremely slow. It will take eons to complete a matrix inversion of that of magnitude. And probably we think that quantum computing might help in that, make it faster, but we don't know yet. In any case, so communication, when you do inverse transform with the matrix inversion, you can finally get audio. And that tells you why the audio is so difficult. You may be able to get all of the components of the IT. What I call IT is consists of image, audio, image, video, text, and the communication video. So, so the text may come in all these things in between. So we can approach from two sides. I think from art, I found recently another conjecture, interesting thing that I found. Art may be an audio image. It connects with the audio. So everything works like a feedback circuit mechanism. So your input, then like the image, and then the output. Then we have throughput, and then we have error signals. The error signals feedback. So it goes to feedback until the error signal is reduced to the minimum level, at which time the output comes. So this is, if you can prove this, use these kinds of concepts, you can prove that why you should be able to understand why the audio is so difficult. You can get all of the components sometime, but not the proper audio. And if you want to understand about superluminite or presence of aliens, you need to get those signals. So we can get other type of signals, and we are transform it using these concepts very carefully of converting the function to a series, and you get a matrix, and then we do the transform of that matrix to get a conjugation. And then from the other side, only because matrix inversion takes forever, so we have to come from the other side. So that becomes audio, produce a trial and error process that produces audio. That audio is going signature, maybe the key to understanding whether there's aliens or not. So we have to approach from two sides, and then because it's a black box after all, like I mentioned earlier. So from the both sides, doing the operations, we should be able to come up with audio signatures, and gravitational waves, for example, are like audio. They're audio sounds, and cosmic microwave background essentially are like images. You should be able to form images from that. So if we connect the two in some ways using these kinds of mathematical operations, we should be able to come up with a way to figure out are there life outside of Earth, and what really is going on, understand more about the black box I'm talking about of the universe. So then we can connect with understanding of dark matter. Many people think that the black holes are a result of the dark matter superluminarity, and they are all connected. The superluminar aspects means is they are not visible. So they are not part of the visible universe, but they are all around us. But they somehow converted to lumina, which is a vacuum, and sublumina, which is a real observable universe. So you can put all these physics aspects and also on the other side mathematical aspects, bring them together, and we may need something called, I have developed something called the gauge algebra. So these two are meshing together with the gauge algebra. Uh, so they all form the complete circuit, uh, to understand more about the universe. So we hope all our research, they are like pieces of puzzle all over the place, but they convert the paradox that into puzzles. So these are puzzle pieces. All of our people, Emmanuel, Christopher, Manuel Malawer, Emery Taylor, John has done a lot of work, John Orch, and then Zan, all our people, and also Christian Wolf and Gerd Pomeranke, who has done a lot of fundamental circuit for the astrophysics, and then try to understand quantum aspects based on the Q factor. So we can put all these puzzles together somehow and try to come up with a proper statement of the problem, and then we can hopefully, once we define the problem correctly, we should be able to find solutions. And I think in that sense, eventually we hope that we can actually connect all these classical physics with quantum physics and relativity, astrophysics, and understand based on the discontinuity of physics itself that we are under with the Emery Taylor. So we may prove that actually the I space may describe the discontinuum aspects. So there is no real zero space, but what we perceive zero is something infinitely far from a distance. A point may appear as zero. So that kind of mathematical finality may be one of the key aspects in understanding and putting together everything, understanding the whole picture. Overall. So that's what we want to get. So that picture is important to understand the physics, and the physics is the most important thing. Mathematics more like abstract aspects. So finally is the physics, which can be proved by many different techniques and experimental methods that's going on. So I think we can get a much better understanding of the physics, of the nature, and of the universe by performing these operations very actively. So thank you very much. And like I mentioned, the last session, special sessions of September 2nd, 2023, last week, that this session is kept open for about 15 minutes, and after 15 minutes nobody else is showing up, we'll close this session, but again we'll continue on 16th. Very similar situation. I will just briefly mention these aspects, what I highlights I have, and then we'll continue from there once Christopher comes back on the 23rd of September. Thank you very much. And if you have any questions, you can always send a feedback to us and let us know what your thoughts are and what the projects are going on. Thank you very much. So we'll talk later. Okay. See you later next week. Thank you.